The question paper level is very easy. Such a simple question they have asked. If we are not in a position to solve it, then gone case. What they are testing is only the basic things they are testing. This kind of idiotic questions they are given, which are very much simple. Such a simple question they have given. Again, why they have given this kind of questions, I don't know. Hello friends, in this video we shall discuss with respect to the previous year question paper on electronic science, which was conducted by NTA UGC NET on 25th June 2025. In the previous video we have discussed from question number 1 to question number 25. If you have not watched that video, links are given in the description. Also you can click on the I button. In this part 2 video I am going to cover from question number 26 to question number 50. In the 26th question what they are given is, if xc of t which is equals to 10 cos of 10 power 8 t plus 5 sine of 2 pi into 10 power 3 t. They are asking what is the maximum phase deviation, that is beta, and what is the maximum frequency deviation they are asking. So they are asking with respect to the values of beta and they are asking with respect to the values of delta f. This equation, sometimes they will be calling it as S of t. You have to compare with the standard equation, that is AC into cos of 2 pi fct. Nothing but omega ct plus beta into sine of 2 pi fmt. Beta into sine of 2 pi fmt. This equation we have to compare. Now tell me what is the values of AC. AC will be equals to 10. What is the value of the carrier frequency, which is equals to 10 power 8 divided by 2. Now what is the value of beta? Beta value will be equals to 5. And what is the value of FM? FM equals to 1 kilo or 10 power 3. FM equals to 10 power 3 or 1 kilo. Now look at the things. On comparison, what is the value of beta? I got beta which is equals to 5 radians. They have given it as a 5 of t max. You can take it as beta. So you are going to get a beta will be equals to 5 radian. And how we are going to define this delta f? We know that beta which is equals to delta f divided by fm. Delta f divided by fm. Now tell me what is the value of delta f. How can I rewrite it? Which is equals to beta times of fm. What is the value of beta, which is equals to 5, and what is the value of fm, which is equals to 10 power 3. So the answer will be 5 kilohertz. 5 kilohertz. So delta f being equals to 5 kilohertz and beta which is equals to 5 radians, the corresponding option that is going to follow is option 1 is correct. For the 26th question, option 1 is going to follow. In the 27th question, in order to find the Thevenin's theorem, like what is the precautions or what is the arrangement you are going to make? We are going to take all the voltage sources as open circuited. It is wrong. We are going to make all the voltage sources as a short circuited. This is correct. And all the current sources are open circuited. And all the current sources are open circuited. So for this, what we are going to do is all the sources are kept as it is wrong. So C and D is going to follow. Option number 3 is correct for 27th. Again I am going to tell, in order to find the Thevenin's resistance or Thevenin's impedance, what we are going to do is all the voltage sources are short circuited and all the current sources are open circuited. Right? So C and D, nothing but option 3 is going to follow. 28th question, the microcontroller 8051 as what is the architecture it is being adopted? So it is 8-bit. Whether it is going to follow Harvard architecture or von Neumann architecture. In the case of von Neumann architecture, both program and data will be stored in a single memory. In the case of Harvard architecture, program and data will be stored in a different memory. In the case of Super Harvard architecture, especially it is used in DSP processors, your program will be stored in one memory, your filter coefficients will be stored in one memory, and your input sequence will be stored in a different memory. Right? So addressing or the program is with one, Data will be 2 in the case of super Harvard architecture, but in the case of Harvard architecture, program and data will be stored in a separate memory. So for 28, which option is going to follow means option number 3 is correct. Nothing but 8-bit Harvard architecture. In the previous part of the video, some of the comments we got. What is the unit of electric flux density? See, I have opted for Weber per meter square. Strictly speaking, it is wrong. I admit the mistake. It is coulombs per meter square. Mubashir, he has responded. Yes, you are right. It is coulombs per meter square. And Poonam, she has replied, stating that pseudo NMOS will be having high package density. No. In the case of CMOS logic, you will be having pull-up network and you will be having pull-down network. But in the case of NMOS logic, the entire pull-up network you are going to replace by a single NMOS transistor, which is of depletion mode or enhancement mode. In the case of pseudo NMOS design, what you are going to do is, the pull-up network you are going to retain as it is. The pull-down network you are going to replace by a PMOS transistor, enhancement mode PMOS transistor, which is connected to ground, nothing but which is always in the on state. So the number of transistors required in the case of pseudo NMOS design will be equals to n plus 1. In the case of CMOS logic, it will be 2n. So pseudo NMOS will be having highest package density when compared to CMOS. So minor correction is required from your end. And also I stated that ECL is the fastest logic. ECL is the fastest logic. So the previous one, what the answer I have given, it is correct, right? Explanations are given, you please go through it. And also Sanobar Khan, she has replied, thank you sir, needed this explanation, please complete the remaining questions also. Yes, we have completed, we are on the go. Shruti, she has told sir, was the paper easy or moderate? See, first 25 questions what I discussed was easy, and this part, what and all the questions I am going to discuss is something like 40% difficult, nothing but not that much difficult, right? So overall the paper is easy only. To score minimum 60%, you will not be getting that much of effort, right? So paper was moderate only, right? Moderate to easy only when compared to the previous years. Concept of explanation helps us a lot. Okay, thank you. Sneha, she has commented, how can we join to a paid course? I will let you know once I will be starting with the things, right? And 20th question, BJT will be having negative temperature coefficient and MOSFET will be having positive temperature coefficient. Yes, my explanation is valid only when the gate to source is of high value, but your explanation is correct. Mubashir, your answer is correct. Hirshika Joshi, she has commented stating that you please complete MHSET remaining questions also. Yes, we will be completing as soon as I can. Now look at the things. Coming back to 29th question, what they have given is, they are comparing with respect to damping. See, 25 divided by S square plus 25. This one, you can write it as 25 divided by S square plus 2 zeta omega ns plus 25. Zeta, you are going to get it as 0. Zeta, you are getting it as 0 means what? It is undamped. So for A, it is 4. So for A, it will be 4. Next, let us solve for third one. So it is 36 divided by S square plus 2 zeta omega ns plus 36. Nothing but omega n square. Omega n, you are going to get it as 6. Zeta, you are going to get it as 1. Zeta, you are going to get it as 1 means this option. C, you are going to get it as 3. So based on this, which option it is going to follow means option 3 is going to be followed. Option 3 is going to be followed. Now look at the things. Remaining things we have to solve. 36 divided by S square plus 70S plus 36. B part we are taking. Now look at the things. Based on this, we are getting omega n which is equals to 6 radians per second. 2 zeta omega n which is equals to 70. Zeta omega n which is equals to 35. Now what is the value of zeta you are going to get? 35 divided by 6, which is very much greater than 1. Very much greater than 1 means what? You will not be getting damping. You will not be getting damping. So for B, you should get 1. For B, you should get 1. So zeta I is very much greater than 1 means what? A very, very slow response. Very, very slow response or rugged response you are going to get. Now look at the things. Zeta value greater than 1, okay, but very much greater than 1 means chances is there that your system may lose the stability. Your system is going to lose the stability. So look at the things. You're going to get a B equals to 2. Why you're going to get a B equals to 2? Important. And now look at the things. For the D part, if you are going with it is 36 divided by S square plus 7S plus 49. What you are going to do? Multiply and divide by 49 you are going to do. Multiply and divided by 49. What is the value of K? You are going to get 36 divided by 49 you are going to get. Now what is the value of omega n? You are going to get a 7 2 zeta omega n, which is equals to 7. Omega n is 7, going to get cancelled. Zeta I equals to half. Look at the things carefully. Zeta being equals to half, you are going to get this option. D, you should get it as 2. Nothing but oscillation do occur, it is going to die. So for D, it should be 2. For B, it should be 1. B equals to 1 is exactly wrong, because zeta I is very much greater than 1 means system is going to lose its stability. Zeta I is just greater than 1 means a slow response or rugged response. If you increase the value of beta, chances is there that the system is going to lose its stability. So for D, it should be 2. For D, they have given it is 1, which is exactly wrong one, right? But A and B is followed, so I have opted for a third option. 30th question, the ascending order of pin numbers of 8086 they are asking. Non-maskable interrupt, it is pin number 17. INTR interrupt, it is 18. LOCK lock, it is 29. And RD bar, it is 32. And min bar MX bar, which is equals to pin number 33. So in the order only they have given A, B, C, D, E. Option number 3 is going to be followed. See what sort of question they have given. We have to remember the pin numbers, it seems. What is the correct option in the case of dI by dt rating of a thyristor? See, you will be having snubber circuit protection, dI by dt protection, or also referred as overcurrent protection. dV by dt protection also referred as over voltage protection. In this case, maximum rate of rise of current from anode to cathode without any arm to the device. Yes, it is minimum rate of rise. No, the energy that the device can absorb for a short time before fault is cleared. Okay, somewhat okay. Eating of the resistive element such as metallic joints, this option can be eliminated so easily. So the corresponding option that is going to follow is option 1 is correct. 32nd question, they are asking to arrange the power amplifiers in increasing order. We know that in the case of class B amplifiers, it is 180 degree. In the case of class A amplifier, it is 360 degree. In the case of class AB, it is 180 to 360 degree. In the case of class C amplifier, it is less than 180 degree. And in the case of class D amplifier, it should be 0. So if we try to arrange, what we are going to get is the first option should be E. Then followed by it is a class C, nothing but a B. Then it is a class B. Then it should be class AB. Then it should be class A. So the corresponding option that is going to follow is option 3 is correct. 33rd question, what they are given is a step index fiber in the case of optical fiber will be having the core with a constant refractive index, that is N1, and you will be having cladding with a slightly lower index. Yes, the refractive index of N1 will be greater than N2. Nothing but the refractive index of core will be greater than cladding. Core will be greater than cladding. So cladding refractive index, you're not going to vary, or sometimes you're going to vary, right? In the case of single mode, N1 you are not going to vary. N1 is varying and N2 is higher than N1, which is wrong. N1 and N2 are same. No. If it is same, then you will not be getting reflections and all. N1 by N2 is equals to 1, nothing but they are telling it is same, which is wrong. So the corresponding option that is going to follow is option 1 is correct, nothing but the refractive index of core will be greater than cladding. 34th question. Dead easy question from H parameter. This kind of idiotic questions they are given, which are very much simple. What they are testing is only the basic things they are testing. That's it. Input impedance with output short circuited. Which one? H11. Reverse voltage gain is what? H12. Forward current gain is what? H21. Output impedance is what? H22. How we are going to represent this H parameter they are asking. That's it. Which and all the variable parameters or which and all are independent parameters. If you are writing and then if you are calculating, you will be getting the answer. V1 which is equals to I2 which is equals to, write the equation, you will be getting the answer. Okay, so for this 34th question, the corresponding option that is going to follow is option 1 is correct. Graphene will be having high thermal conductivity. The conductivity of graphene will be more, and the carbon nanotube which is going to exhibit sp2 hybridization, right? So for A it is 2 and for B it is 3. Which option it is going to follow? Option 1 is going to follow. That's it. Now look at the things. In this question, what they are asking is, they are asking us to arrange the class amplifiers in accordance with respect to the power efficiency. Important. In the case of class A amplifier, the efficiency is 25%. Theoretically, it will be 50%. That's it. And in the case of class B amplifier, it is 78.5%. Now look at the things. Class AB should lie in between. So it is 50% to 78.5%. Now look at the things. Class C amplifier which is less than 90% and class D which is greater than 90%. So when you try to arrange in an order, so what we are going to get, first it should be A only. Then it should be class AB. Class AB means B. Then it should be class B. Then it is which one? Class C followed by class E. So the corresponding option that is going to follow is option 3 is correct. 37th question. The resolution of 4.5 digit voltmeter they are asking. Now what do you mean by 4.5 digit is important. You will be having 4 digits to represent over here. That's it. Now, this place can take from 0 to 9. This place can take from 0 to 9, 0 to 9, 0 to 9. Whereas, this half digit can take either 0 or 1. This can take either 0 or 1. Now, look at the things. If I am fixing the point over here, decimal point over here, what will be the first value? 0, 0, 0, 0, 0. Nothing but 0 only. Now look at the things. If I am going with the next digit, what I am going to get? 0.0001. So the minimum reading that you can able to get from the device is nothing but your resolution. What is the maximum value I can count? 1.9999. This is on the minimum end, provided that I have fixed the decimal point over here. You can fix the decimal point anywhere and everywhere of your choice, right? So I am considering here what is the minimum value that I can able to read from this digital voltmeter. If you are fixing the decimal point over here if you are fixing, then it is 0.00001 you are going to read. 0.00001 you are going to read, right? Important, right? But in most of the cases, what we are going to do is we are going to fix the point somewhere over here. We are going to fix the point somewhere over here, right? 1 point something, because the 0.0000, that much of values why you are in need, right? So this question is a tricky question. Just come up with your answers. What should be the answer for this 37th question? According to me, my answer is third one. 38th question is dead easy. Low pass filter, it is going to allow the at lower frequencies, it is going to allow. At higher frequencies, gain is very low. Low pass filter, very small gains at high frequency, yes. High pass filter, high gain at high frequency, at low frequency it will be having low gains. Okay, so for 1 it is 2, and for B for A it is 2, and for B it is 1. Option 2 is going to follow. Band pass filter, only a band of frequencies it is allow. It is going to allow, right? So high gain for a band of frequencies, yes. And band reject filter means only some frequencies it is not going to allow. Very small gain for a band of frequencies, right? So for C it is 4, D equals to, that is 3. So the corresponding option that is going to follow is option 2 is correct. Option 2 is correct. 39th question, again dead easy question. The propagation constant already we have discussed in the class session, gamma, which is equals to this formula, under root of zy. Now, so for C, you're going to get it as 1. Straight away you'll be getting the answer. Now look at the things. The reflection coefficient usually you're going to represent by gamma, right? Like this you're going to represent. But in this they have given it as a tau. So you have to follow what is the convention they have given. That's it. You have to follow the convention what they have given. That's it. Now look at the things carefully. Look at the things carefully. The standing wave ratio rho you are going to get, which is equals to 1 plus gamma divided by 1 minus mod gamma. Now say suppose mod gamma which is equals to 0, then rho will be varying from 1 to, say suppose gamma equals to 1. Here they have given tau equals to 1. Then the standing wave ratio will be varying from 1 to infinity. It will be varying from 1 to infinity. Important. Then the reflection coefficient gamma, which is going to vary from -1 to +1. Here they have given the reflection coefficient as tau. Now how we are going to define the reflection coefficient gamma, which is equals to ZL minus Z0 divided by ZL plus Z0, and the characteristic impedance is given by this one. So the corresponding option that is going to follow is option 2 is correct. 40th question, 8259 is a programmable interrupt controller. Yes, it is a programmable interrupt controller. Interrupts are hardware or synchronous in nature, which is wrong. 8086 will be having 20 address lines. So it will be having 16 address lines, but the physical address, if you are thinking that, the physical address will be of 20-bit wide. So the addressing capability will be of 20-bit. Data bus, which will be of 16-bit. Control bus is of 16-bit. So C option is also correct. RQ bar slash G1 bar and RQ bar slash GT naught are used in a minimum mode of operation. It is wrong. 8087 is a coprocessor of which one? 8086 microprocessor. This statement is also correct. So ACE is correct. Nothing but option 3 is going to follow. Important. Now this question, you see, you try to comment your answer in the comment section. Based on those fellows, how they have solved, I am going to teach you. Look at the things. This is a non-inverting configuration. This is non-inverting configuration. In the case of non-inverting configuration, what will be the value of gain? Gain which is equals to 1 plus RF divided by R1, which is equals to 1 plus 20K divided by 10K, which is equals to 1 plus 2 will be how much? 3 you are going to get. So the gain will be equals to 3 you are going to get. Look at the things carefully. Op-amp is in negative feedback. Okay. Virtual short is valid means not valid. Why? The open loop gain should be very high. But here the open loop gain is restricted. The open loop gain is restricted. So you can't make use of any sort of formulas. In the case of inverting, it is minus RF divided by R1. In the case of non-inverting, it is 1 plus RF divided by R1. All these formulas are not valid. Why? It is valid only when virtual short is satisfying. When virtual short is satisfying, when the op-amp is in a negative feedback and you should not have any saturation. Nothing but what? A gain should be more. Here, what is the open loop gain? Open loop gain is just 15, which is a very, very low value, right? It should be of 10 power 5. What is the gain? Gain is a low value. So, in this kind of question, is the formula applicable? You please comment your answers in the comment section, right? 42nd question, the system is said to be stable if the output is unbounded for bounded input. It is wrong. The output is bounded for bounded input. Yes, the output is bounded for unbounded input. If you are getting that kind of response, means the system is the best one. Again, I am going to repeat. For the unbounded input, if you are getting the bounded output, your system will be the best one. Now look at the things. What we need is all the roots should lie on the left half of S plane. All roots are in the left half of S plane. Yes. 43rd question. MOSFETs. Look at the things. You will be having active region and you will be having saturation region. Let us compare with respect to MOSFETs and BJT. I am going to write a table. You please try to remember. MOSFETs in a saturation region will be acting like a current source. In the linear region, it will be acting like an amplifier. Reverse case will be in the case of BJT. In the linear region, if you are operating the BJT, it will be acting like a current source. In the saturation region, it will be acting like an amplifier. So, MOSFETs in a saturation region will be acting like a current source, right? So, MOSFET is biased in saturation region for amplifier application, which is wrong. MOSFET is biased in a linear region for amplifier application. It is correct. BJT is biased in saturation region for amplifier application. Correct. BJT is biased in active region for amplification purpose. It is wrong. MOSFET is biased in saturation region for realizing a resistor. Up to some extent you can able to use it. The characteristic impedance of a uniform plane wave in a free space V is given by eta equals to under root of mu by epsilon, which is equals to under root of mu. You can write it as mu naught mu, or epsilon you can write it as epsilon naught times of epsilon r. You can rewrite this one as mu naught divided by epsilon naught into under root of mu r divided by epsilon r. Mu naught is 4 pi into 10 power minus 7. Epsilon naught equals to 8.854 into 10 power minus 14. So what you are going to get? Eta, which is equals to 120 pi into under root of mu r times mu r divided by epsilon r. Free space mu r and epsilon r equals to 1. So what you are going to get? Eta, which is equals to 120 pi, which is equals to 377 you are going to get. For 44th option which is going to follow is option 3 is correct. 45th question, the location of flags in the case of 8086 microprocessor, you have to arrange in an increasing order. So if I start arranging, what you are going to get is the first one will be the carry flag. So A you should get first. Then if you start looking at next, you are going to get a 0 flag. Next you are going to get a 0 flag. 0 means what? D you should get. Followed by you should get the trap flag, followed by direction flag. Then you should get the overflow flag. The corresponding option that is going to follow is option 4 is correct. While I was explaining the flag register, how I have told you to remember means in one day international Tendulkar scored 0, all people cried. If you were in a position to remember this cheat code, you would have answered this question so easily. 46th question what they have given is, again this is a simple question what they have given. The schematic of CMOS inverter is, now look at the things. In the case of CMOS, you will be having pull-up network and you will be having the pull-down network. Your pull-up network, you're going to make use of PMOS transistor, and pull-down network, you're going to make use of NMOS transistor. In the case of inverter, you will be having one PMOS network and one NMOS network. That's it. So look at the things. Option 2 is going to follow. Option 2 is going to follow. Same input, same gate, shorted gate you're going to give. Look at the things. This bubble is there to indicate for PMOS. The corresponding option that is going to follow is option 2 is correct. Such a simple question they have given. Again, why they have given this kind of questions, I don't know. The question paper level is very easy. A silicon diode has a saturation current of 5 nanoampere at 25 degrees centigrade. What is the saturation current at 95 degrees centigrade? Now look at things. For every 10 degree rise in temperature, the current or the reverse current will get doubled. 35 degrees centigrade, what happens to the current? 10 nanoamperes will be the current that will be flowing. At 45 degrees centigrade, 20 nanoamperes. At 55 degrees centigrade, a double 40 nanoampere is the current that will be flowing. Now look at the things. You still further increase. At 65 degrees centigrade, you are going to get 80 nanoampere. At 75 degrees centigrade, you will be getting 160 nanoampere. At 85 degrees centigrade, you are going to get 320 nanoampere. At 95 degrees centigrade, what is the current they are asking, which will be equal to 640 nanoampere. You can make use of the formula and then you can able to solve it, or you just go with this blind method. For every 10 degree rise in temperature, the current doubles. That's it. The ohmic resistance of a JFET is given by, we know that the transconductance GM, which is equals to dou ID divided by dou VGS. Dou ID divided by dou VGS. What is the value of ID? You are going to get a 10 milli divided by 4, which is equals to 2.5 milli you are going to get. 2.5 milli you are going to get. Now what is the ohmic resistance RD, which is given by 1 divided by GM, which is equals to 1 divided by 2.5 milli. If I am sending on the numerator, it will be kilo. 10 power 3, 1000 divided by 2.5, you are going to get it as 400 ohms only. So for this, the corresponding option that is going to follow is option 4 is correct. Option 4 is correct. Now look at the things. We know that IDS, which is equals to IDSS into 1 minus of VGS divided by VP the whole square. This formula they used to ask, but this time they are asked with respect to ohmic resistance of JFET. This question is somewhat considerable one. 49th question, you see, again it's a dead easy question. In the case of NMOS, what I told you to remember. Now look at the things. The current is out of, or the substrate current will be into, in the case of NMOS. In the case of PMOS, what I told, it is just a reverse case. That's it. It will be just a reverse case. The current will be into, substrate current will be out of. That's it. In the case of enhancement, you have to create a channel. In the case of depletion, already channel will be there. See, already the channel they have told, it is a depletion. Here it is enhancement. Here it is a depletion mode. Here it is enhancement. Now look at the things. You have to tell whether it is a NMOS or PMOS. Look at the things. The current is outward, but the substrate current is into. So it is NMOS depletion. NMOS depletion. Right? Now look at the things. The current is outward. So it is a PMOS enhancement. PMOS enhancement. Now look at the things. This is depletion mode. The current is outwards, so it is a PMOS. So it is a PMOS depletion. Here it is enhancement mode. The current, substrate current is into, so it is NMOS. So it is a N-channel enhancement type MOSFET. So for A it is 1. For B you are going to get a 4. For C you are going to get it as 2. For D you are going to get it as a 3. So the corresponding option that is going to follow is option 2 is correct. Such a simple question they have asked. If we are not in a position to solve it, then gone case. Last question. So friends, till here, if you are not liked the video, please give it a big thumbs up. Now look at the things carefully. The type 4 interrupt represents, which it is going to represent means overflow interrupt. Type 4, it is going to represent overflow interrupt. Which option it is going to follow? Option 2 is going to be followed. Now look at the things. Type 0 refers to division by 0. Type 1 is for single step execution. Type 2 is for NMI, non-maskable interrupt. Type 3 will be for breakpoint interrupt. You please go through the things carefully. So friends, in this video we have covered from question number 26 to question number 50. All the questions are easy to moderate level only. In the next part of the video, we shall cover from question number 51 to question number 75. If you have understood with the solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you. And for the test series, you can make use of cravinggyan.com. Thank you friends. All the best for your exams.